Welcome to the Explainer. You know, in the race to build smarter AI, the main strategy has pretty much always been to just go bigger. More data, more computing power. But what if the real answer isn't about size, but synergy? Today, we're diving into a really cool idea. What if AI models could learn as a collective, sharing their breakthroughs to get smarter together?
Okay, so here's how we're going to break this down. First, we'll talk about the huge problem in AI post-training right now. Then, we'll introduce this new, decentralized solution called SAPO. After that, we'll look at the actual experiment that put it to the test, dig into the pretty impressive results, and finally, explore what this all could mean for the future of collective intelligence in AI.
All right, so let's set the stage with the big problem. We all want AI that can reason, that can solve complex problems and really think logically. But actually teaching it to do that, well, we're hitting a serious wall.
And this is really the core challenge, isn't it? How do we keep making these models smarter without the costs and the sheer complexity just spiraling completely out of control? The traditional approach of just throwing more power at it, well, that's reaching its limit. We need a much more clever solution.
Now, one of the most powerful ways to teach AI these complex skills like logical reasoning is something called reinforcement learning, or RL. Instead of just force-feeding a model millions of labeled examples, RL lets the model actually try to solve a problem. It gets a reward if it gets closer to the right answer, and it learns from its own successes and failures. It's kind of like how you or I would learn a new skill, really. But here's the catch. Trying to apply this trial and error method to these giant AI models is, well, it's a logistical nightmare. Just imagine a huge team where every single person has to move in perfect lockstep. It's incredibly expensive, it creates massive communication jams, and the whole system is just super fragile. One little hiccup can bring the entire learning process to a grinding halt.
So, if that old, rigid, synchronized system is the problem, what's the solution? Well, this paper proposes a pretty fundamental shift in thinking. Move away from that centralized system and toward a flexible, decentralized swarm.
And the proposed solution is called SAPO. The core idea is just brilliantly simple. Stop trying to synchronize the entire brain of every single AI model. Instead, just have them share their experiences. This means the models can all work independently, at their own pace, on totally different hardware, and still learn from the collective wisdom of the group.
So this is the crucial point right here. When one model in this swarm has a breakthrough on a really tough problem, an aha moment, it doesn't just keep that insight to itself. It shares its experience, which the paper calls a rollout, with the whole network. The single successful attempt can then bootstrap the learning process for every other model in the swarm.
And here's what that cycle looks like in practice. First, each model goes off, tackles problems, and generates its own experiences. Then, it shares some of those with the swarm. Now, this third step is critical. Each model then puts together its next lesson by mixing its own experiences with some valuable ones it pulls from that shared pool. And finally, it updates itself. It's this constant loop of individual work and shared wisdom that really drives the progress. Now, it's a fantastic idea in theory, but does it actually work in practice? So, let's dive into the experiment the researchers set up to put SAPO to the test. So, what they did was create a swarm of 8 identical, relatively small language models. These models were then given a whole range of problems to solve from the Reasoning GM dataset. We're talking everything from algebra and logic puzzles to abstract reasoning. And the whole thing was run on a decentralized framework, really simulating a real-world swarm environment.
All right, now for the exciting part. What actually happened when these models started sharing their experiences? Let's dig into the data and see the results.
First up, let's look at the baseline. This is the control group, 0 sharing. Each model is completely on its own, learning in isolation. And the result? Well, you can see the performance, which is measured here as reward, just inches up, very, very slowly. They're learning, sure, but it is a real grind.
Now, watch what happens when we enable sharing. In this test, each model is learning from a 50-50 mix of its own work and the experiences it gets from the swarm. The difference is just staggering. Look at that. The performance spikes are way higher, and they're happening much more often. The entire group is suddenly learning faster and achieving way more.
So just how much better is it? The final number is pretty striking. This balanced sharing approach led to a 94% improvement in the total reward earned by the swarm. That is nearly double the performance, just by letting the models learn from each other. This graph here smooths out all that noisy data to show us the average performance over time, and it makes the story crystal clear. That red line at the bottom, that's our isolated models, just struggling along on their own. The green line, way up above it, is the swarm, using that balanced sharing strategy. It is consistently and significantly higher. This proves the benefit isn't just some random spike, it's a sustained real advantage.
But, and this is a really crucial nuance the research found, more sharing is not always better. It turns out, when the models relied too heavily on external experiences, like in this case, where they used only 2 of their own rollouts and 6 from the outside, their learning actually became unstable. You can see these strong oscillations. It suggests that while a model gets a huge boost from the swarm's wisdom, it also needs to ground its learning in its own direct experience. There really is a sweet spot for sharing.
Okay, so we've established that SAPO works incredibly well in a controlled lab experiment. But what about in a messy, unpredictable, real-world environment with thousands of different participants?
Well, the researchers actually tested this in a large-scale public demo with thousands of contributors. And guess what? The principle held true. You can see here that the swarm models, in blue, they initially learn at about the same pace as the isolated models in orange. But then, right around round 175, that collective learning effect really kicks in, and the swarm just pulls ahead with a clear, significant advantage.
So, let's just quickly recap the key takeaways here. SAPO offers a much more scalable and cost-effective way for AI to get better at reasoning. The real magic is in letting those aha moments spread through the network like wildfire, which bootstraps everyone's learning. And crucially, it shows us that the best results come from finding that perfect sweet spot between learning on your own and learning from the group.
And all of this leaves us with a final, pretty provocative thought. This research, it isn't just about a new algorithm. It's about a whole new paradigm for how AI learns. If models can learn from the active, live experiences of their peers and not just from static data, what new forms of collective intelligence are just waiting to be unlocked? We are truly just beginning to find out.